Hello Precalculus student, this video is for chapter 5.4, right triangle trigonometry. And we are using the SOHCAHTOA definition of sine, cosine, and tangents to find missing sides of a right triangle. Remember, it's a right triangle. And then we're doing the second example where we have two right triangles stick together. If this side is 90 degrees, or we know that this angle is also 90 degrees. So on this side that has x1, part of x, we would have x1 and 82 in the middle and a 63 degree. So I can solve for x1, right? So relative to 63, 82 and x1 are O and A, right? TOA. So I would say tangent of 63 is equal to 82 over x1. So multiply x1 on both sides. So x1 times tangent 63 degree is equal to 82. So x1 would equal to 82 over tangent 63. So we don't need to calculate it yet because our ultimate goal is to find x, which is x1 plus x2. So maybe I'll write it here. X is x1 plus x2. So if we can find what the formula or what expression is x1, then we can do it at the end. So what is x2? X2 would be this part. It is part of another right triangle. Relative to angle 39, this is also OMA, TOA. So use tangent of 39 because this is the angle and one side, two side, right? So it's always relating one angle and two side, and it's TOA. So that is 82 over x2. So likewise, we multiply x2 on both sides, so almost the identical way of solving it. And then x2 would be also 82, but divided by tangent of 39 degree. So now we're ready to calculate x. X is x1 plus x2, so be 82 over tangent 63 degree plus 82 over tangent of 39 degree. I advise you to do it this way instead of do both of these separately and round it and then round again. So if you do this, then you would have one less rounding error accumulating. So 82 divided by, what was it, 10? Is it 82? Yeah, 82 tangent 63 and tangent 39 divided by tangent 62. It is degree, right? Plus 82 divided by tangent 39. Is it 30? 63. Right. Okay. Correct. And then we just add them 143. If I round it to the nearest unit, is 143. Or 143.0 for tenth. The next one is also two right triangle. You can say it's two right triangle. One is this one. One is this one, and the other is the smaller one. So we are to find x. Okay. So how do I find it? So if I know this and 63 is for the smaller one, I have one side. They didn't ask for this, but I would like to find this, like we call it y, for example. It's just from here to here, y. Because this triangle is a triangle, but it's not a right triangle. We would have to use this big one. But for this big one, I would be able to use 115 to find the whole thing, but I can't find the small x. So what the plan is to find the whole thing later on, which is x plus y, using this big right triangle and then subtract y, and that would be x. So let's find y first. So y is what? Is this side, this angle, and this length. This side is A, this is opposite. So again, we use tangent. Tangent 56 degree is equal to 115 over y. So I multiply y on both sides. Tangent 56 degree is equal to 115. So y is equal to 115 over tangent 56 degree. So that's that. We won't do it yet. And then we have to use this big triangle. So this big right triangle is also, we have a one angle. This is the missing side. Let's say this is x plus y, and this is the known side. So I have two sides, again, OA. Right, again, tangent of 35 is equal to 115 divided by x plus y. Right, x plus y. So I multiply both sides by x plus y tangent of 35 is equal to 115, tangent 35 degree. But y is 115 over tangent 56. So maybe I would just multiply both sides by, distribute this out. So I would have x. Oh, well, actually, I'm going to divide both sides by tangent 35. Maybe it's easier that way. So x plus y is equal to 115 divided by tangent 35. Okay, and then what is x? X is 115 over tangent 35 degree. I should write degree because it's confusing. Minus y, but y is tangent 56. Minus 115 over tangent 56. So there I have the whole expression of calculating x. So I'm going to put in my calculator. Oh, it's very good. It's similar to what we did before. 115, but I do subtract, right? To subtract tangent of 35 and 56. 35 here, 56. You might worry, oh, would I get a negative number? No. Tangent 35 is lower than tangent 56, so this number is bigger. 86.7. So round to one decimal place is 86.7. So that's how we find x. So when you have two right triangles, sometimes you have to do something like that. So other work problem would involve what? Involve like observing something in a distance with angle of elevation and angle of depression. So angle of elevation is, suppose someone is here and this person observes something at the top of the tower. This angle is called angle of elevation. So you are looking up to look at something. This is your eyesight. This is the line of sight, or we call it. And then the line of sight with the horizontal, this is this. And assuming the observation is done on the ground, of course. And conversely, if this is not a tower, but like a building or something, someone stand here and look down at something, then the angle that the persons form with the horizontal is called the angle of depression. So it's always this angle or this angle. It's never about the vertical. Okay. So for example, the angle of elevation to the top of a tree. So draw a tree, so the top of a tree. So assuming someone observed the tree over here, right? So this, to the eyesight, and this is the angle of elevation is to the horizontal. It's 57 degree when a person is 30 feet from the ground. So this normally a person is not on the ground, but we just assume that the observation is from the ground. Find the height of the tree. Otherwise, you have to add the height of the person. Okay. So height is here. And you see that there is a right triangle here. We assume that the tree is stood vertically. So a right triangle, one angle, this is the missing side, h, and this is the adjacent side, 30 feet, right? So you have to formulate, you can formulate a TOA ratio. 57 is equal to h over 30. So h would be multiply 30 on both sides. 30 tangent 57 is equal to h. So how tall is the tree? Is 30 times tangent 57. So then with this, 30 times tangent 57. So 46.2 if you want to the 10th place. 46.2. 46.2 feet. So they have units, unlike those triangle that we worked on before. A radio tower is located 355 feet from a building. So let's say this is a building that's really small. This is a radio tower is really tall, like what is the highest radio tower in San Francisco? I don't know. But but the radio tower usually is a very tall building. A person determines the angle of elevation to the top. So in from a building. So this person from a window in the building, we don't know where it is, so just somewhere. So this distance is 325. And the angle of elevation to the top of the tower is 43. So angle of elevation, so this is 43. And angle of depression to the bottom of the building, so this is the eyesight to the bottom, and that would be 31. So see how it is always to the horizontal. Okay, this one. So how tall is the towers? So this would be finding these, right? Very similar to what we done before. We have actually two right triangle. Basically, we would do x1 and x2. So the total tower is total tallest is x1, x2, and we would use one. If this is 325 horizontally, this would be also 325. So A and O relative to 43. So we have tangent 43 degree is equal to x1 over 325. So x1 is equal to multiply 325 on both sides. 325 times tangent 43 degree. Similarly, in this right triangle, angle 31 for x1 is opposite. For the 325 is adjacent. So tangent of 31 degree is equal to x2 over 325 also. So x2 multiply on both sides, 325 tangent of 31. And then the total tallest of the building is x1 plus x2 equal to 325 tangent of 43 plus 325 tangent of 31. So gotta write the answer here. Let's use this 325. Just rewrite this 25 tangent of I don't remember 31 and 43. So 43 first plus 325 tangent of 31. So that's the answer. Oh, I forgot the T. There. 498.3. 498.3. What is it in? It's in feet. Okay. So write the proper unit. The next example is a ladder. So this kind of question shows up a lot in calculus. So you need to get used to this kind of question. A ladder leans against a building so that the angle between the ground. So this is the ladder. Kind of like that. Okay. But we draw it as a line, and you walk a bit this way. So this is 30 feet. But lean on the building so that the angle between it and the ground is 80 degrees. So 80 degrees. So it is not. In scale, of course, how high does the ladder reach up to the side of the building? So that means what is h here? Okay, so we have this side, relative to 80 degrees. This is the hypotenuse, and that's the O. O and h, that is saw. So that means sine of 80 degree is equal to OH. No, O is, it's really, maybe I'll call it H because H means hypotenuse, so it's very confusing. So it's X, which is O, over the hypotenuse, which is 333, right? So to solve for X is equal to 33 times sine 80. So 33 times sine 80. It's really easy when you have this decimal scientific calculator, 32 point, let's say 5. Well, if I want to round to one decimal,